Hello students. So today we are going to look into another small concept or an algorithm in our fourth module, which is called as EM algorithm, right? So it's also called as EM algorithm, or we call it as the expectation maximum algorithm. Now, for what purpose this expectation maximum algorithm is being used? So generally, we are going to use this, or it is basically used to find the local maximum likelihood parameters of a statistical model, right? So we are going to find, once again, by using this EM algorithm or expectation maximum algorithm, we are going to find the local maximum likelihood parameters in such cases where our data is missing or incomplete. So whenever you don't have the data, if the data is missing, now you are going to find a particular value, right? You are going to predict a value for that missing value, and you try to keep on maximizing its expectation. That is, you want to find the maximum likelihood. So for this particular purpose, we are using this particular algorithm. So now the EM algorithm, it follows this particular algorithm. Now we can say generally it consists of two sets, or we can say two steps. So we are going to consider a set of parameters which is incomplete data set. Like, say for example, so now in our class, so we have got 100 students are there. Now I want to find the average weight or average height of all the students. So I want to conduct a survey. Now one particular day, now when I take the data, when I start collecting the data, what are the height of each and every student, now assume that only 80 students are present, right? 80 students are present, 20 students are absent. So now I don't have the data of 20 students, right? So I have got the data of only 80 students are there with me. So now what I do is that since these 20 data is missing for me, so I don't have this 20 data, so I will use this EM algorithm. Now I will predict these 20 values, right? These 20 data I am not having, they are absent in the class, but I want to collect 100 data sample. So now we are going to estimate these 20 values, and then we try to see that we try to maximize this. So the first step, what it says here, expectation step. That means in this step, or this step is used to estimate the value of missing values in the data. So now 20 students are absent, 20 values are missing. Now we are going to estimate these 20 values, right? So now it involves the observed data to basically guess the values in the missing data. You observe this 80 data, you observe the weights of these 80 students and guess the remaining weights of 20 students. Because 20 students are missing, I am going to guess the weight. Now when you guess the weight of these 20 students, are they correct? Because you are just guessing. So you want to see that this guessing is more appropriate, so that you are going to converge. So now we go for second step. Second step, we says maximization step. Now this step generates the complete data after expectation step. That means once you perform first step, then you apply this step. That means, so expectation step means what? Now 20 data are missing, so you guess 20 data. So now you put in this, now you will say that you have got around 100 data, right? 80 was the actual data and 20 you have guessed. So now with this set of data, now we update the missing value to the data. Now we try to maximize this 20 data. Now we are going to see, we keep on iterating this until the convergence is met. Now what do you mean by a convergence? We know that your expected is something, you observed data is something, you try to find the difference, you are going to get the error term. The more and more the errors are less, your prediction is correct. So we want to see that the error term is less, or you want to increase, or what we say in the other terms, maximize the likelihood of your hypothesis, right? So now the concept of convergence in probability is based on intuition. Now let us say that we have two random variables. If the probability of their difference is very small, it is said to be converged. So we have to see that the whatever the probability we are trying to do, now it becomes very small, so that if it is small, errors will be small, and we are going to say that it is going to converge. So now we can try to draw a flowchart also for this algorithm. We are going to start, we have some initial value, expectation step, right? You are going to expect some or guess some of the variables. Then we go for maximization step. Now where you are going to maximize the values, right? So you try to maximize these particular values. So now after maximizing, now we are going to check whether it is converged. So whether it is converged or not. If it is converged, so that means if the errors are reduced, so then we are going to stop the algorithm. If it is not converged, so again we go to the expectation step. So that means you are going to find some other, or you are going to make a different guess, and once again you start the same process. So this is how you are going to identify, or you can try to draw a simple flowchart to see that now how we are trying to apply this particular algorithm, right? So now this is the basic idea. So basic idea why we are using this particular algorithm is, now you are having some missing values, so you guess the data for that missing values. Now what all the guess you are doing, you have to see that these guesses are more appropriate for us, right? So if it is not, again you make a guess. So we keep on repeating this particular algorithm. So that is why now we are going to use this particular. So now what are the use of EM algorithm? So now we can say that it can be used to fill the missing data in our sample, right? So just now we have discussed. Now it can be used as a bias for unsupervised learning of clusters, right? Now when you have got some of the unsupervised learning, so we can just bias it. So by default you are going to assume something. Even it can be used for estimating some of the parameters of our like say hidden Markov's model, right? These are some of the models which comes in our learning. So right now we need not discuss, it is out of the scope of the syllabus. So now we can say that in order to discover the values of a latent variable, like we said that in our belief network, so there might be some entities, certain parameters, where in order to identify that, directly we cannot do it, right? So now at that time, so based on its superclass, now we are going to make a guess. So in that cases or missing data, we can try to use this algorithm. So in many practical learning settings or learning algorithm, only a subset of relevant instance features might be observed. As I said that some features, some of the instances we cannot observe it. We cannot observe those particular features. So but we can observe its parent. So then we can derive that particular features. Like when you are talking about this bias and belief network, now you say for example campfire, we cannot observe the features of the campfire, but we know that this is dependent on storm and bus tour group. If you can observe these two data, with these two data we can derive this campfire. That's what it says. So many approaches has been proposed to handle the situation when you don't have the data, when there is an unobserved variables. So like it can be a bias and belief network, or we can use our EM algorithm. And this EM algorithm is widely used approach to learning in the presence of unobserved variables. When you have got missing variables, when you are having unobserved variables, so then this is one of the popular algorithm what we are going to use. Now it can be used even for variables whose values is never directly observed. Either it is missing value or directly you cannot observe the variables, but it can be observed with the help of joint probable distribution of its parent classes, right? So now how we are going to do this? So to understand this, to apply this algorithm, so we are going to consider the estimating means of K Gaussian distribution. Now Gaussian distribution is nothing but your normal distribution, right? So it is a normal distribution. When you are talking about a normal distribution, now you will be having a bell shaped curve. So now this is how the curve we are going to get a normal distribution. Say for example, when you are going to find, let us say, the average weight of our entire class. Now you can see that when you are considering the average weight of entire 100 students or entire class, majority of the average weight of all the students, it might lie in this region. Now there will be only few students whose weight is very very less, or there might be very few students whose weight is very very high, but in an average everyone falls in this particular range. So it can be shown, it can be drawn as a normal distribution, right? If you are taking the number of students as y-axis and x-axis as their height, this is how the diagram you are going to get. So now consider a problem in which the data D is a set of instances generated by a probability distribution that is mixture of k distance normal distribution. Now not one, more than one, right? Now this is a diagram. In this example, now we have taken two normal distribution. Now you can see here, now this is your first normal distribution, we can call it as k1. Now this is the second normal distribution, we can call it as k2. On our x-axis we have so many data points, right? So there is a data points are there. Now when you are going to guess or estimate some of the data points, now it might fall in k1 distribution or it might fall in k2 distribution. Like say for example, what we told, we have the height of 80 students but we don't have the height of 20 students. Now 20 students who are absent on that particular day, now you are going to guess and put some values there. You are going to put some height of those students. Now these 20 heights, what you are going to consider, now these 20 heights, they may come from this distribution k1, or it might come from k2 distribution also. Now when you are considering this normal distribution, what happens, many of the time the data will be skewed. We say the data will be skewed. The skewed means, now you will say you will get a like this graph. So that means you will be having a x and y axis instead of a normal bell shape. So you might be having a graph like this. So that means majority of the data is skewed to either left side, or the data will be skewed towards the right side like this. Not exactly a normal distribution. So in that cases also, now we can this EM algorithm can be applied. So now the problem setting is illustrated in this diagram where we are considering k is equal to 2. That means two normal distribution k1 and k2, where the instances are the points shown in the x-axis. Now these will be the instances, right? So you are going to guess these instances. Now these instances, now if you take this one instance, it can come from either k1 or it can come from k2 also. So any one distribution we are going to have. So now each instances now is generated using two-step process. Now how you are going to generate these instances? How you are going to make a guess? Now it is generated in two step, because this EM algorithm applies two step. The first is, one of the k normal distribution is selected at random. Now you have two distributions, you are going to select any one, either k1 or k2 randomly. You are going to select one distribution. Then second step, a single random instance xi. Now if suppose say you are going to take k1 distribution. Now for this k1 distribution, you are going to select one instance xi is generated according to the selected distribution, and this process is repeated to generate the set of data points. So like this, you are going to generate 20 data points, because 20 data points are missing, right? So generally first step, you are going to select any one distribution randomly. Like say for example, you take k2 distribution. Now in this k2 distribution, in this entire k2 distribution, you are going to assume you are going to generate one data point, right? Second data point, out of 20, now one you generated. Now second one you are going to make a guess. You might take a k1 distribution. Like this, now we keep on doing. Now this process is repeated to generate a set of data points as shown in the diagram. Now to simplify, let us consider a special case where the selection of single normal distribution, right? Now single normal distribution at each step is based on choosing each with uniform probability. So that means now we are going to assume that, so whatever the distribution you are going to take, now all these are uniformly probability distribution, where each of the k normal distribution has same variance sigma square. So the variance should be the same. That means normally if you are going to select k1 two times, k2 also you are going to select two times. So like that. So the variance is normal, where this variance is known for us. So we are going to have the same variance. Now what do you mean by variance? Variance is the square root of standard deviation. right? Now what is standard deviation? If you want to calculate standard deviations, you are going to find the mean of all the data point mu, then you take individual values, right, xi, you are going to find the difference, square this and divide by the total number of sample space, so which gives us the standard deviation, and square root of that standard deviation is the variance. So now what we are going to do is that now we are going to select or choose each with a uniform probability where each of k normal distributions have the same variance. So now the learning task is to output a hypothesis. Now we want to have an hypothesis H such that H is equal to mu1. What is mu1? Mean. So mean should be the same. So when mean is the same, so then your variance also will be the same. So you should have a hypothesis H is equal to mu1, mu2, etc. up to mu k. So for k1 distribution, mu1, one mean, another distribution, another mean, that describes the mean of each of these k distribution. So you are going to find the mean of these k distribution. So now we would like to find the maximum likelihood hypothesis, because now you stated a hypothesis H. What is that hypothesis H? Now you are going to calculate the mean of all these distribution, mu1, mu2, etc. of all the distribution. So now you want to find a maximum likelihood hypothesis for these mean, that is maximum likelihood hypothesis means what? Now you are going to maximize the probability of this data point given this hypothesis H. Right? Now it is easy to calculate the maximum likelihood hypothesis for the mean of a single normal distribution. Now when you have got a single normal distribution, it is very easy for us to find the maximum likelihood hypothesis. Now how do you find the maximum likelihood hypothesis? By this equation, already we know it. Now we write this as, instead of HML, in our previous module concept we have written H, maximum likelihood hypothesis H. But now this hypothesis is what here we are going to calculate the mean of all the distribution, k Gaussian distribution, right? So instead of H, now we represent it as mu. Mu of maximum likelihood is nothing but what? Argmin. You have to minimize the error, you have to minimize the square sum errors, right? Argmin of, for summation for I is equal to m to m, xi minus mu whole square, right? So your mean, you are going to find the difference, square of errors you are going to reduce. So you are going to find the argmin, which will be the maximum likelihood, right? So this is HML, already we have discussed in the previous modules, right? Now that we are going to call it as mu here. So we already know that maximum likelihood hypothesis is the one that minimizes the sum of squared errors over m training instances. Now in this case, this sum of squared error is minimized by sample mean, because we are going to consider the mean. So you are going to, here you told you are going to calculate or consider the mean of each distribution, right? So now this sum of squared errors, now it is nothing but our mean. So it is the sample mean. So what is your sample mean? So it is nothing but 1 divided by m summation for I is equal to m of xi. So sample means what? It is an average. So if you have got 10 data points, now how do you calculate sample mean of this? Add all these 10 divided by 10. Add all these 10 values, average, right? That is what we are doing. Sum all these and divided by m. So which is called as the sample mean. So now this is replaced with our sample mean, right? Now one problem here involves a mixture of k different normal distribution. Since we don't have only one distribution, we have so many distributions. So we have got k different normal distribution, and we cannot observe which instance was generated by which distribution. Now it is very easy, you are going to calculate the mean, but we don't know if you are going to generate one xi, whether this xi comes from k1 distribution or whether it comes from k2 distribution. It is very difficult for us to identify, right? So that is the problem for us. Now how we are going to overcome that problem? So now we are going to consider a triplet. So we are going to consider a triplet xi. It is the What is this xi? Where xi is the observed value for the ith instance. You are going to consider an ith instance xi, comma zi1 comma zi2. So y2z we are writing. So we are considering two normal distribution k1 and k2. Already we have seen, right? So we have seen that diagram. So we have got one normal distribution, we call it as k1. Another normal distribution, we are going to call it as k2. So now we say that xi comma zi1. So when you are going to observe an ith value xi, right? Now this I, it can come from either this distribution, or like say if the distribution curve is like this, it can come from k1 or it can come from k2. It may obey either k1 or k2, right? So where xi is the observed value of the ith instance, where zi1 and zi2 indicates which of the two normal distributions were used to generate xi. Now to generate xi, whether you have used k1 or whether you are used k2. So that, to represent that, we are considering it as a triplet. Now what values you are going to put here? Now it is given here. In particular zij, right? Zij has a value 1. So we say that if xi, if instant xi is generated from the first distribution k1, right? If you are going to generate it with k1, so then here zij value becomes 1 here. Zij has a value 1 if I was created by the jth normal distribution. If it is generated from k1th distribution, now this value will be 1 and this value will be 0. Otherwise it will be 0. If that instance xi is generated from second distribution, then this zi, now this value will be 0 and this value will be 1. That is how we are going to how to make a difference that this xi came from k1 distribution or k2 distribution. So if the values of zi1 and zi2 were observed, we are going to use this equation. Now when you look into the values of zi1, zi2, now here we can say that we can use this equation argmin. Previously we told it is very difficult to use that. Now we are trying to get this. Now to solve for the mean mu1 and mu2, right? So in order to find this mu1 mean for k1 distribution or k2 distribution, we can use this equation. But we cannot use this equation. The reason is that if you are going to generate an instant xi, it is very difficult to say that it belongs to k1 distribution or k2 distribution. If you know that it belongs to k1 distribution, then you can calculate mu1, right? If it belongs to k2 distribution, you can calculate mu2. If you are able to find that, then it easily you can find the mean, whichever is having the minimum mean, that is your maximum likelihood minimum, right? It is easy to find. But since it is very difficult, because this zi1, zi2 are hidden variables, it's very difficult to identify that it belongs to which distribution. So to overcome that, now we use EM algorithm. Here our expectation maximum algorithm comes into the picture. So now apply to the problem of estimating the two means from that diagram, the EM algorithm first initializes the hypothesis H equal to mu1, mu2. What we do is, first step, now we are going to take an hypothesis and we find two mean, that is mu1 and mu2, where mu1 and mu2 are the arbitrary initial value. You don't know what is the mean, right? So we give some arbitrary value first. After taking an arbitrary value, then we iterate, then we iteratively re-estimate this H. We keep on re-estimating this H by repeating the following two steps. So we are going to follow these two steps and you keep on repeating that until you are going to, the procedure converges to a statutory or stationary value of H, until you get a better value of H. Now what are the two steps you are going to do? Step 1, you calculate the expected value E of Zij for each hidden variable Zij. You are going to calculate an expected value for this hidden Zi. assuming the current hypothesis h equal to mu1 and mu2. So first initial step, you arrange some values for mu1 and mu2. Next, you calculate a new maximum likelihood hypothesis h dash. Now you are going to calculate h dash, which is equal to mu dash, mu1 dash, right, and mu2 dash, mu1 dash and mu2 dash, assuming the value taken on by each hidden variable zij is its expected value from the previous step. Already we made an initialization, then we find a new value. So now then we are going to replace the hypothesis h by this new hypothesis h dash, and we try to do it. So these are the two steps we are going to do. In practice, how we are going to do, we will see it. So what it says that you take an initial value mu1 and mu2 as hypothesis h, then you calculate a new maximum likelihood hypothesis h dash, where you are going to find new values of mu1 and mu2, and you update, and you keep on repeatedly, you keep on doing this until it converges, right? This is the theoretical how we are going to do this particular task. But in practically, how we are actually finding that, right? Now that is given as follows. Now what we do, first step, what we told, first step 1 must we calculate the expected value of each zi. So you are going to calculate the expected value of zi, right? So you are taking two here, two normal distribution k1, k2. That means you have to find mu1 and mu2. So what is that mu1? Mean is nothing but that is the expected value. So now this E of zij is just the probability that instance xi. Now what is the probability? What is the chances that a value xi is being generated by the jth normal distribution? What is the likelihood? What is the probability that this xi is generated by this distribution? What is the probability that xi is generated by this distribution? You are going to calculate, right? So now we say E of zij equal to probability of x is equal to xi, right, for any instance xi, and mu is equal to mu j, right? So it belongs to the average weight, so expected value, so which belongs to that particular distribution, whether it belongs to the k1 distribution or whether it belongs to the k2 distribution, divided by, right? So it is nothing but divided by summation for I is equal to 1 to 2, because 2 distribution we are using, and probability of same x is equal to xi given mu equal to mu n. So this first step is implemented by substituting the current value of mu1 and mu2 and the observed xi in the above expression. So now how we are going to do this? Now since we are considering normal distribution, now we take the general equation of the normal distribution. So now our general equation for normal distribution is given as 1 divided by square root of 2 pi sigma square, right? 2 pi sigma. So this is how we write 2 pi sigma, here this is sigma square multiplied with e to the power of minus 1 by 2 sigma into xi minus mu j whole square. So now in this standard equation of normal distribution, the first term is constant, so we ignore this constant and we are going to consider this term. So here you can see this is equal to probability of x equal to xi for any instance, and what is the probability that it belongs to a particular distribution, right? That is the expected value mu to a particular distribution. We are going to find it with this equation, that is e to the power of minus 1 by 2 sigma square into xi minus mu j, right? So you start taking each data point minus, you are going to find the mean of that particular distribution. What is the probability that it comes from which distribution, whether it comes from k1 distribution or whether it comes from k2. If it is k1, for that k1 distribution find the mu 1 or mu j in general. So square divided by square root of n is equal to 1 to 2 of, now again probability, so we are going to write the same equation e to the power of minus 1 by 2 sigma square into xi minus mu n whole square. So thus the first step is implemented now by substituting the current value of mu1, mu2 and the observed xi value. Now in the second step, now we use this xij. Now this you have calculated by this equation. Now we are going to use this value expected Eij calculated during our previous step to derive a new maximum likelihood hypothesis. Now you are going to find a new hypothesis h dash, which is equal to mu1 dash and mu2 dash. Now you want to find a new mu dash, right? Now how do you find that? So that is found by this equation. So the maximum likelihood hypothesis, now we can say mu j is equal to summation for I is equal to 1 to m and the expected value of zij multiplied with xi. We are going to find the weighted expected value or mean. See here, expected value E, what we are going to call here E of zij is nothing but the mean, right? So now you are going to find the mean. So you find all the mean, multiply with that x value divided by summation I equal to 1 to m and the expected. So this expression is nothing but our sample mean that is used to estimate mu for a single normal distribution. So now once you got this new value, so we can call this new value is nothing but mu dash. So our new expression is just the weighted sample mean for mu j with each instances weighted by the expectation E of ij, that is generated by the normal or jth normal distribution, whether you are taking k1 distribution or the k2 distribution. Now this is how, now these two steps we keep on doing this until the value converges, right? So now the above algorithm, this above algorithm for estimating the means of mixture of k normal distribution, it illustrates our expectation maximization algorithm. So now the current hypothesis, how we are going to say now, we can finalize the current hypothesis is used to estimate the unobserved variable. Since we are just making a guess, then we keep on calculating until it converges. So we are going to estimate an unobserved variable and the expected value for these unobserved variables are then used to calculate an improved hypothesis. Right? Each time you are going to find h dash. So it can be proved that on each iteration through the loop, the expectation maximum algorithm, it increases the likelihood, right? It keeps on increasing the likelihood, that is probability of that particular data set given the hypothesis. Here hypothesis is the expected value or mean what you are going to identify. So we keep on doing this until this algorithm converges. So converges means, so that difference, that is the mean what you are going to find, it has to reduce. So then only we are going to get the maximum likelihood hypothesis. So this was the algorithm which is called as EM algorithm or expected maximization algorithm. So sometimes this algorithm can be asked in our as a short note in the examination, right? Now try to understand this particular algorithm. So in a very brief, you want to say why we are using this algorithm when you have got a missing value. So when the data is not there, when there are unobserved facts, so now you can derive. So if you are using the Bayesian belief network, then you use the concept of joint probability distribution in order to find that. Now here this is another way of trying to do it. So we have different way. One is your belief network, right? Belief network through which you are taking joint probability distribution and you are going to derive the unobserved data. Now this is another way how we are going to handle the missing value. Clear? So I think it's little bit complicated, mathematics or equations are there, so you have to read and try to understand this, right? So this this about our almost maximum topics we have covered in our the fourth module, right? So next we will go for our the hypothesis. Till now what we told, this is an hypothesis we are trying to do. Now evaluating an hypothesis. how do you say that hypothesis is correct? How are you going to evaluate? So those things we'll be discussing in our next topic. Okay, thank you, have a nice day, bye bye.